Triplex wire is typically not permitted for installation in underground PVC conduit. The primary reason is that triplex wire, which usually consists of multiple conductors twisted together without an overall jacket specifically designed for wet locations or direct burial, does not meet the requirements for underground installation. Electrical codes mandate the use of wiring methods specifically approved for such environments to ensure safety and prevent premature failure of the wiring system. When running electrical wiring underground, whether directly buried or installed within a conduit, it is crucial to select conductors and cables rated for wet locations and, in some cases, direct burial. Common approved wiring methods include THWN, THWN, UF cable, and direct burial rated cables. THWN stands for thermoplastic high water resistant nylon coated. This type of wire is suitable for wet locations within a conduit. A THWN insulation provides moisture resistance, making it appropriate for underground conduit runs where water or condensation may accumulate. THWN stands for thermoplastic high heat resistant nylon coated. THWN wire is primarily designed for dry or damp locations but can be used in wet locations if it also carries a W designation, such as THWN. UF cable stands for underground feeder cable. This type of cable is specifically designed for direct burial applications. It has a durable outer jacket that provides protection against moisture, chemicals, and physical damage. UF cable can also be used in underground conduit runs. When installing wiring in underground PVC conduit, it is essential to adhere to all applicable electrical codes and regulations. The National Electrical Code, NEC, provides comprehensive guidelines for electrical installations, including underground wiring. Local codes may have additional requirements or restrictions, so it is crucial to consult with the local electrical inspector or authority having jurisdiction (OJ) to ensure compliance. Several factors must be considered when selecting and installing wiring in underground PVC conduit. These include the depth of burial, the type of soil, the presence of any corrosive substances, and the potential for physical damage. The NEC specifies minimum burial depths for different wiring methods and voltage levels. These depths are intended to protect the wiring from damage caused by digging, vehicular traffic, or other activities. The type of soil can also affect the performance and lifespan of underground wiring. Some soils may be corrosive or may retain moisture, which can accelerate the deterioration of certain types of insulation. In areas with corrosive soils, it may be necessary to use special types of wiring or to provide additional protection, such as encasing the conduit in concrete. The presence of any corrosive substances, such as chemicals or salts, can also damage underground wiring. These substances can leach into the soil and attack the insulation and conductors, leading to premature failure. In areas where corrosive substances are present, it is important to use wiring that is specifically designed to resist corrosion. The potential for physical damage is another important consideration when installing underground wiring. The wiring should be protected from damage caused by digging, vehicular traffic, or other activities. This can be achieved by using rigid metal conduit (RMC) or intermediate metal conduit (IMC), or by encasing the conduit in concrete. In addition to selecting the appropriate wiring method and providing adequate protection, it is also important to properly install the wiring. The conduit should be properly sized to accommodate the wiring, and the wiring should be installed in accordance with the manufacturer's instructions. The conduit should also be sealed to prevent moisture from entering. When pulling conductors into the conduit, use a pulling lubricant approved for the type of insulation on the conductors. This will help to reduce friction and prevent damage to the insulation. Do not exceed the maximum pulling tension specified by the manufacturer. After the wiring is installed, it should be tested to ensure that it is properly grounded and that there are no shorts or grounds. This can be done using a multimeter or other testing equipment. It is also important to keep accurate records of the underground wiring installation. These records should include the location of the wiring, the type of wiring used, the depth of burial, and any other relevant information. This information will be helpful for future maintenance and repairs. Always consult the NEC and local electrical codes for specific requirements and regulations regarding underground wiring installations. Failure to comply with these codes can result in safety hazards and code violations. When running underground wiring and PVC conduit, the individual conductors must be rated for wet locations. This means they must have a W designation in their insulation type, such as THWN or XHHW. These conductors are designed to withstand moisture and prevent electrical hazards. Firstly, consider the wire type. THWN, as mentioned earlier, is a common choice for wet locations. It is a thermoplastic high-water resistant nylon-coated wire that is suitable for use in conduit, including underground PVC conduit. Secondly, consider the conduit fill. Ensure that the conduit is properly sized to accommodate the number and size of conductors being installed. Overfilling the conduit can make it difficult to pull the wires and can also damage the insulation. The NEC provides tables that specify the maximum number of conductors allowed in different sizes of conduit. Thirdly, consider the conduit depth. The NEC specifies minimum burial depths for underground conduit, depending on the voltage and location. These depths are intended to protect the conduit from damage and to prevent electrical hazards. Make sure to comply with these requirements. Fourthly, consider the connections. All connections must be made in approved enclosures that are suitable for wet location. Use waterproof connectors and fittings to prevent moisture from entering the enclosures. Fifthly, consider grounding. The grounding system must be properly installed and maintained to ensure electrical safety. Grounding conductors must be properly sized and connected to the grounding electrode system. Sixthly, consider inspections. Have the installation inspected by a qualified electrical inspector to ensure compliance with all applicable codes and regulations. This will help to identify any potential hazards and ensure that the installation is safe. Seventhly, consider documentation. Keep accurate records of the installation, including the location of the conduit, the type of conductors used, and the results of any tests or inspections. This information will be helpful for future maintenance and repairs. UF cable is designed for direct burial and can be used in conduit, but it's generally more expensive than individual THWN conductors. Also, pulling UF cable through long conduit runs can be difficult due to its stiffness. Another approved option is direct burial rated cables that can be buried without conduit. These cables have a robust outer jacket that provides protection against moisture, chemicals, and physical damage. However, local codes may require additional protection, such as encasing the cable in concrete in certain situations. In summary, when installing electrical wiring underground, always use wiring methods that are specifically approved for wet locations and, if applicable, direct burial. Consult the NEC and local electrical codes to ensure compliance with all applicable requirements.